So tonight we are going to do a little experiment together in Try This at Home. We've got a Don't Lick That episode looking at something called methanol, and we're going to do something called What Are You Looking At? And then we've got a piece of medical equipment to show you to we're going to start with this. Try this at home. Try this at home. Try this at home, and all you need to do today is have 2 fingers and your nose, and we're going to see if you can feel what it's like to have 2 noses. There's 2 ways of doing this experiment, okay? So you can either use your nose, or if you've got a bit of plasticine or a little bit of blue tack, we can use that, or a bit of Play-Doh, something like that, like roll it into a little ball, okay? So what we're going to do is we're going to cross our fingers and we're going to place our nose between them like that, okay? So 2 fingers, cross them over. I'm trying not to swear at the screen. Okay, and then put your fingers either side of your nose. And I want you to close your eyes, and I want you to just focus on what you can feel on the inside of your fingers there. And you're just going to move your fingers up and down your nose like this, okay? Or you cross your fingers and put a ball of plasticine or Play-Doh in between the 2 fingers in there and roll it backwards and forwards on your hand and see what you can feel between kind of the little gap in there, okay? Now what you should feel after a while, just take a few maybe kind of seconds, maybe a minute or so, just really focus and concentrate on what you're doing, okay? And you should start to get a sensation of having 2 noses. Why is this? Well, it's all to do with how the nerves, the sensory nerves in your fingers, are mapped to your brain. I've got some pictures to show you, okay? So we've got something called the homunculus in our brain. This is how our body is mapped to our brain. This is one section. So if you imagine my head here, okay, we've kind of cut it in half. Hang on, I'm going over here like this. Cut it in half. We're looking at it straight head on, and we've got like a slice that we've pulled out of my brain that you're looking at. You can see all the different body parts are mapped to it. So if I was to tickle my toes, it would kind of go to that toe section up in that corner just up there. If I was to burn my lips on my tea, the sensation would go to, where's it going to go? Over there on that part of my lips, on that part of the screen there. Okay, so if we kind of rotate, so you're going to look at my head from the side and look at this strip of tissue in our brain that kind of where all our senses go and where all our sensations go. I've got like 3 bands there, and these are going to be where the information from our fingers go, okay? So we've got our 2 fingers on the screen like that, okay? And what I want to kind of do is map them to the colours. And if you look, the insides of your fingers when you don't cross them are the same colour. This means kind of the same information. The information from here goes to pretty much the same part of your brain. So if you kind of just rub your nose like this, your brain's getting information from your fingers that it's roughly in the same area of your fingers. They're kind of almost like they're stuck together, okay? So these 2 bits of kind of skin here, the information pretty much goes to the same part of the brain. So your brain picks that up as being one spot. However, when you cross them over, look where the light blue and the green are. They're on the outer edges of my fingers, so on this edge and this edge here. But when we cross our fingers, they end up being on the inside. So we've got 2 outer bits now when we cross them over being next to each other. And when these signals go up to our brain, we get 2 bits of the brain light up. Not just the one from the inside of your fingers, but 2 because they're separated. The nerves from these outer edges go to 2 different parts of this sensory cortex. So your brain starts to interpret this as you touching 2 different things and not one thing, like your nose. So when you're touching your nose like this, it makes it feel like you're touching 2 different noses instead of one. It's pretty awesome, isn't it? So that's today's episode of Try This at Home. Let's go and have a look at, where should we go next? Let's do... Hey, you don't lick that! Don't lick that. Now this is a little story. This is not about a medicine. This is about a chemical that when ingested can be very, very dangerous. Hello, who we got? Someone's just jumped online. Let's have a little look. Who we got? Hello, Yusuf. Nice to see you here, Yusuf. Love that you're a big fan. Big fan of you too, mate. Good to see you here. So let's have a look at this poison or this chemical. And this chemical is called, oops, daisy, hang on, look over to the slide. I've jumped ahead of my slides. I'm showing you all the answers here. There we go, there we go. Live streaming, should have reset that. So, the poison we're looking at is something called methanol. And this is a type of alcohol. And you know it's an alcohol because it ends in OL. Anything ending in OL is an alcohol. There's lots of different types. So the alcohol in drinks that adults drink is a type of ethanol, okay, the type of alcohol there. And this is methanol, not the same thing. Very, very dangerous. And last year, I think it was last year, in Southeast Asia, there were some tourists that were poisoned with methanol because some scrupulous bar owners were putting methanol in the alcoholic drinks to water it down or make it stronger so they could save a bit of money. Okay, not good, because when people start to drink this, okay, unexpectedly, they didn't know they were drinking this, it was kind of all unexpected. What can happen is it gets processed by your body and causes some problems. So methanol goes into your body when these tourists drank it, and it is processed by their liver. And their liver and our livers have all got this enzyme called alcohol dehydrogenase. Now don't worry too much about the name. Obviously people get kind of a bit freaked out with scientific names, but it's called alcohol dehydrogenase. And what it does, it turns the alcohol in methanol into something else. It turns it into this chemical here called formaldehyde. Now your body takes this and it turns it into something else called formic acid. And this little thing is the dangerous bit. Okay, so we put methanol into our body. That is actually doesn't do anything. It makes you feel drunk, maybe, but it doesn't have any kind of real major toxic effects until it's turned into formic acid. Okay, now the good thing is your body has a way of getting rid of formic acid. It's got a taxi for formic acid. Taxi for formic acid. Okay, it's called glutathione, and that's in your body. It's in your liver. It's a little molecule, and it mops up dangerous things, and it picks them up. Okay, think of maybe a taxi going around picking up kind of hooligans and drunk people at the end of a night. But it picks up formic acid, locks it away, so it can't do any damage, and then this gets excreted in our wee. Okay, we get rid of it, and it gets processed, and out it goes. But the problem is, we've only got a limited number of taxis in our body. So if we overload it with too much formic acid, it starts to build up because we haven't got enough taxis to pick it up and carry it away. So what happens is formic acid ends up going into parts of our cells called the mitochondria. Now this is where your body uses oxygen and makes something called ATP, adenosine triose phosphate. And these are our energy molecules. This is what muscles and our cells use when we say we're burning energy. When we eat food, the ultimate end product from this food is we're making these things called ATP. But we need oxygen to do that. And what formic acid does, it stops us using oxygen in our mitochondria. It suffocates them. Okay, not great. And what happens is we stop making ATP from what we call aerobic respiration. So we're not using oxygen to make our energy. We have to do something called anaerobic respiration. And you can experience this if you go and sprint really fast up the stairs or down the street, that burning sensation you get, you're using anaerobic respiration. You're making energy without oxygen, okay? But the thing here is, because it's the only way we're making oxygen in a methanol poisoning case, we get loads and loads of lactic acid building up. It's not good. When we're doing exercise and we get lactic acid building up, we can get rid of it fairly quick. But here, we're just adding more all the time. And ultimately what happens, we get something called, a medical condition, called metabolic acidosis. And all this means is our body becomes very acidic from our metabolism. And what can happen is we get faster and deeper breathing because we're trying to get rid
of something called carbon dioxide, which helps reduce the acidity, okay? All our blood vessels start to open up and dilate. They get bigger, so you become very hot and very flushed. And our heart contracts much weaker. When our body's acidic, our muscles don't like it and they contract really weakly. And what can happen, we can go into something called shock. And that's basically when your heart and your cardiovascular system can't push blood around your body because your blood vessels are really wide and your heart is beating really weakly, all from becoming too acidic. And there's another side effect too. Formic acid can get into your brain and damage the neurons in your brain and in your eyes. So there's a risk of blindness. There's a risk of your brain swelling up. Neurons can die, and you can end up having seizures as well, and kind of Parkinson's type symptoms. So Parkinson's, people tend to shake a lot. Okay, so it's not a great bit of poisoning going on here, but there is an antidote. And the antidote is normal alcohol. Vodka, for example. So if this happens really quickly, if someone realises they're drinking methanol really, really quickly, if you got to hospital, they would probably give you, or try and find, some form of alcohol to give you to help fight. I want to show you how it works, how it can help. But in a serious case, we can put ethanol as a medicine into their veins and directly into their blood flow. Okay, they would get drunk from doing that. How crazy is that? You're going to make someone drunk to get them better. But what happens is we put in 2 alcohols into the body. We've got methanol in the body, and we're going to put some more in with, say, like some vodka or something, and it's going to fight and compete with the methanol for that enzyme, that alcohol dehydrogenase, and the liver stops making formaldehyde. And if we stop making formaldehyde, we can stop making that folic acid, that formic acid, sorry. And if we stop making that, we don't get poisoned, because that's the poisonous bit, not the methanol, it's the formic acid. And what happens now is methanol, we just excrete it in our wee and we breathe it off on our breath. You get kind of a very smelly breath, and we can get rid of it like that way. So it gets put into our airways and we breathe it out, or we can put it into our wee and we wee it out, but it takes a long time to do that. So it's not a quick process, but there is an antidote. And I love sharing that story because I just love the fact that the antidote is more alcohol. How weird is that? What do you think of that, Yusuf? That's quite deep physiology, that one. Should we go to have a look at how
medical kit works.
How medical kit works. I'll say that too quickly then. And we're going to have a look at a piece of kit here called an infrared vein scanner. That's an infrared vein scanner. And if you ever had blood taken and they can't find your veins, this piece of kit would have been very, very useful, because you can shine it on your skin and it shows up your blood vessels a little bit like this. You see that above me there? Those are my veins underneath my skin, and they're being projected onto my skin by a device like this. How cool is that? It makes your kind of blood vessels just glow underneath your skin. Now this is really useful for when we want to try and find veins for taking blood. And obviously we've got lots of different types of patient. We've got young and old, we've got different skin colours, different ethnicities, we've got different skin thicknesses as well, and different types of skin health. All of those variables impact on how well we can see our veins when we want to take blood. And we can just shine this over our skin and we can see the veins more clearly. But how does it work? Well, I'm going to show you. So this machine, let me just adjust my picture there. Hello. Let me just adjust this live on YouTube. There we go. That is a very weird camera. There we go, that's better. Look at that. So what we've got is we're going to shine out of here some infrared light that we cannot see. So infrared light we can't see. So look at the end of your remote control on your TV. Press the button, you won't see the light. We can't see, it's not in our visual field. We can't see that in that visual aspect, in our visual spectrum. But infrared light goes into our hand and it penetrates our skin by a couple of millimeters. Okay. What happens is your skin absorbs some of that infrared light and bounces back
a little bit of light. We still can't see that, but it bounces back a slightly different wavelength. So a wavelength of light goes in, and then a slightly different one comes back from our skin. But the hemoglobin in our red blood cells that are in our veins, because the infrared light will go into our veins, so the hemoglobin in those red blood cells in your veins also absorbs some of that infrared light, but it bounces back another different wavelength. So we have one wavelength of light going into our skin, and then we have two going back. And the device has got a sensor in here, and it picks up those differences. And then it projects, or it creates and projects a video of your blood vessels onto your skin in real time. So this just uses infrared light. It's pretty cool, isn't it? Just to come and find your veins so we can take some more blood. Yusuf, what do you think of that? Let me know. If anyone else is watching the chat, drop a comment in there. So let's have a look at our final segment this evening, which is...
What a ride! What about? What are you looking at? What are you looking at?
What are you looking at? And this is going to be kind of a regular feature where we're going to show you some different medical images or videos of different scans, and we're going to see if you can guess what you think you're looking at. Now this week I've started quite easy because it is quite obvious what you're looking at. I hope it is quite obvious. So get ready on the chat if you're on there and let me know what you think this is. What do you think? I'm hoping you can hear me. I think my sound's gone.
There we go, I'm back. What do we think? What do you think that is? It's quite obvious, I think. I'm going to give you the answer. It is your heart. Well, it's my heart, in fact. And it's kind of looking straight on. I've got a little arrow I'm going to put on the screen so we can kind of point different things. So this is the tip of the heart, the very bottom. So the way the probe works, the image is kind of skewed and upside down. So this is the bottom, this is the top end over here. This big kind of chunk right through the middle, that's called the septum, and that separates the left and right sides of the heart. But the thing I really want to show you on here, which is really, really cool, I don't know if you've ever heard the phrase, someone's pulling on your heartstrings. If you're falling in love, or someone's fancies you and they're pulling on your heartstrings, this is where it comes from. Okay, so we've got this kind of finger-like projection that goes into one of the ventricles here. Can you see that? That is called a papillary muscle, and it's like an anchor at the bottom of the ventricle. And if you look really closely, you can see like a little bit of stringy thing attaching onto this flap over here. If you just look at that carefully, you can see that. This muscle and this stringy thing move in time with that flappy thing there. Or mechoey, okay. I wonder if that helps. Sorry, I don't know why mechoey. Let me just see what I'm doing here. Hopefully that's better. Okay, so those stringy things, that kind of big chunk here, is called the papillary muscle. And this bit of here is called the chordae tendineae. And it's a tiny, tiny little bit of tendon that attaches onto this muscle and onto the valve. And it keeps the valve in the right position so it doesn't flip the wrong way and the blood can flow freely. So it makes sure the blood, if this is the valve, it shuts like this and the blood comes up, and it shuts and stops the blood coming through. So when the heart beats, it goes, it comes through and it stops. Okay? Or if you do it the other way, the blood comes through and then it shuts and it stops them flipping the wrong way. So it's like a guide rope. Okay, really, really cool. And that's the papillary muscle and chordae tendineae. Okay. If you watch closely, you can also see my heart have an arrhythmia too. So watch this. So it's beating normally. It goes bump, 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 bump. Watch this now. Bump, bum, bum. Is that little double twitch there? Do it once more. Bump. This is normal. Bump. See it twitch then. Got a little twitch. So this is normal now. There you go. Keeps twitching like that. Thanks for letting me know, Amanda. Apologies, it's echoey. It's really cool, isn't it? But that is an ultrasound of my heart. So, if you've got any questions, drop them in the chat. Stick online for a few minutes. If you've got any questions, want me to show you anything again, I'll happily answer those. But that kind of brings our episode of Monday Night Medicine to an end. I'd love to know
as well. Thank you all for watching. Hope you enjoyed that. I'm off to go and pick my son up from Cubs. Hope you had a great evening, and we'll see you again next week for some more bite-sized science bits to help your brain grow. See you later.